Hello everyone, welcome back to my channel. Suhail this side. So guys, today we will be designing or discussing the LLD problem, which is very commonly being asked in most of the interviews. So we will be discussing the publisher subscriber library, right? So let's see the problem statement. So the problem statement is we have to design a publisher subscriber library or module which can be used by many of your internal services, right? So for example, you are already working in an organization, right? And you are being asked to design a publisher subscriber library which can be used internally by other team members or by other modules in your organization. So you have to design in such a manner that the code should be maintainable, extensible, and it should be in such a way that any future enhancements can be incorporated in an easy manner, right? So what are the what are the requirements actually, right? So there can be multiple publisher and subscriber threads. So this is the requirement number one, right, which would complete this publisher subscriber library. So the second requirement is user should be able to stop the publisher and the subscriber. So as and when if user wants to stop that particular library so that no further messages should be published or they subscribed by the workers, right? So user should be able to do that as well. After that, once user do that, so no messages should be published and the subscribed. Now the third requirement is there should be a provision to run the client code when message is published successfully and message is received successfully. For example, in real time, if you have already used some kind of libraries, for example JMS, RabbitMQ or Kafka, right? So there they provide the callback functionalities, right? The callback methods which you can override and you can provide your own behavior, right? For example, the on message received, right, or the on message method you need to override, and in that method, when that method would be called, that method would call once you receive the message, so that you can incorporate your business logic. For example, you want to persist some information into the database. For example, if you receive the order update event, right, on the worker thread, right? So what the worker thread can do, they can deduct the inventory, right? So count minus can be done in the inventory for the product which are placed in the order, right? So all these callbacks you need to be provided. So this library should support this functionality as well, right? Now the fourth requirement is there can be different type of messages sent over this library. For example, the order updates, notification updates, right? So there could be multiple few more kind of use cases, right, in which this publisher subscriber library can be used, right? And the requirement is the order updates. Let's assume the order updates and the notification updates, right? These are the two use cases, right, which has to be supported by this publisher subscriber library. So if order updates or the notification updates, there is a very high inflow of notification updates, so your order update should not be delayed and vice versa, right? So in short, this updates or the processing of these messages should be in isolation, right? The order update should be processed in isolation with respect to the notification updates and vice versa, right? So this is the fourth requirement. And last but not the least, your library should be generic enough to publish and consume any kind of data structure, right? But so guys, whenever interviewer or you are being asked to design any publisher subscriber library or any publisher subscriber module, right? So usually what questions you need to ask to the interviewer, right? So first question you can ask is whether what would be the behavior for this publisher subscriber library. Is it a push based or is it a pull based? So there are two kind of approaches for designing publisher subscriber library, right? So the two approaches are, first is the push based and the other is the pull based, right? In push based, what happens, the publisher already knows what all subscribers should be notified. So as and when new message comes or new message is published, so the publisher will notify or invoke the subscriber, okay, that this is the message, you can process it. So this is a kind of push based mechanism. But in case of pull based mechanism, what happens is subscriber keeps on polling, keeps on checking from the publisher, okay, are there any new messages, are there any new messages, are there any new messages, right? So as and when there are new messages, subscriber can take it and process it, right? So this is a kind of pull based mechanism, right? So in this section, in today's video, we will be designing a pull based publisher subscriber library, but in the next video, very next video, I will be designing the push based publisher subscriber library, right? So stay tuned, that video would come very soon, right? So guys, first point, we will be designing this library considering the fact we have to follow all these solid principles, right? So we have to write a code in such a manner that it should be extensible and it should be maintainable for any future enhancements. So we will be challenging all the design discussion, all the, you can say, design principles, right? We will keep challenging ourselves, okay, that why we are not creating the interface, why we are not creating the abstract class, what happens if this is the case. We would be challenging each and every design decision, right? So watch the complete video till the end, it would be fun to watch, right? So we will be designing and discussing all the trade-offs which has to be taken while designing this library. So without wasting time, let's get started. So for a publisher subscriber library has to be developed, right? As the first requirement states, there should be multiple publisher and the multiple subscriber threads. So if I visualize it, right, if I visualize it, let's see how it would look like, right? So it would look like this, right? So there could be multiple publishers and there could be multiple subscribers. Now for publisher to publish the message, right, there should be some mechanism where the message would be stored, right? And subscriber can keep checking that particular mechanism or the intermediate data structure, okay, are there any new messages placed into this data structure or not, right? So that subscriber, as and when it sees, okay, there are new messages, it can process it, right? So with this visualization, what flow comes to our mind, okay, there should be some kind of publisher class, there should be some kind of subscriber class, and the other kind of what data structure, the shared resource, as we have discussed in the earlier multi-threading videos, right? The shared resource is the message queue, right, where the actually the messages would be stored. And this is the basic, you can say, basic paradigm for any kind of publisher subscriber library, right? You can take it Kafka, Revit, MQ, anything. So you would see the intermediate messaging queue, right, which will hold all the messages. So that is how we can visualize it, okay? Publisher, subscriber, message queue, and message queue should be the shared resource which would be used by the publisher as well as subscriber. Publisher keeps on publishing the messages to the queue, and subscriber keeps on checking from the messaging queue that, okay, are there any new messages placed into this queue? Okay, yes, if there are new messages, subscriber can take it and process it. So let's write the code for this, basic code for this particular, you can say, particular block, right? So let's write the code for it, right? How we would write this code. So for this, I have created the design pub/sub, and v1 is this is the first version, the base for any kind of publisher subscriber library, right? So the base would be, considering we are creating the base, so I am creating the v1 package. So as and when we keep on doing modifications, I would keep that in v2, v3, and the similar kind of packages I would made, right? So what we discussed, we need the publisher class, right? So let's create the publisher class, right? The publisher class should be there, okay, we got it. Now what would be the other class? The other class is subscriber class, right? So that is also there. Now what was the other intermediate data structure where we want to keep the messages? That is under the message queue, right? Let's create the message queue, right? So these are the basic three classes, standard basic, that which has to be existed in any kind of publisher subscriber library. Now what we can see, visualize, okay, there could be multiple publisher threads and there could be multiple subscriber threads. So if we have to support multiple publisher threads, so what we need to do, the publisher class, how we can create threads, as we have discussed earlier in the earlier videos, publisher has to implement the runnable interface, right? Let's implement the run method for this. And similarly, subscriber has to implement the runnable interface, and this is how we can um, provide the thread behavior, what publisher would do and what subscriber would do. Right now the other thing is, just now we have just created the basic skeleton. Right now let's see the messaging queue, what it should hold. Right, so this data structure, this class, what it would hold, it would hold the messages. So to hold the messages we need some kind of data structure, right? For example, the private list, right? And let's start with the very basic. As and when, if in any case, whenever you are being whenever any problem is being thrown on you, right, you have to design this, that. So firstly, just break the problem into smaller statements, right? Because we have seen in the requirement that we have to support the generic functionality so that the messaging queue can hold any kind of data structure, any kind of data structure which can be published as well as subscribed. But to break this, let's start with the very basic that is already existed. For example, the string. For example, you don't need to create your own data structure. Okay, I'll create custom data structure and I'll put there. No, just start with the very basic. Let's start with the string, right? So what we will do, we will create a queue and the other is linked list, right? Linked list would fill our purpose, right? So that as you already know, linked list in Java is by default a doubly linked list. What we can do, the insertion can be happened at one end and first in first out we can support it very easily. Right now you have the queue, the linked list is already there. Now what else you need to provide? You need to provide the two methods, right? For first method should be publish method, right? What it will do, it would add into the queue as and when you got any message, right? As and when you got any message, this message has to be added into a queue, right? We are done. Now what else we need to do? We need to provide the subscribe method, right? So what it will do, it will just we just need to write the subscribe method. Now what it will do, it will first check, right? It will first check if the queue is empty. If the queue is not empty, right, what it will do, it will just do queue dot remove 0, right? So that is our job, right? Otherwise what it will do, it will do return null, right? Publisher is done, publish message is done. What publish would do, adding the message into the queue. Subscribe method, it will just remove the message from the queue. We are done, right? Message queue, we are done. Now what we need to do, we need to provide the publisher and the subscriber implementation. Let's but now publisher, what the run method of the publisher would do, publisher run method would be publishing messages to the queue. That is what. So for very simpler use case, what we can assume here is there should be some kind of for loop, right? And we can assume for int I is equal to 1, I less than equal to 5, right? What we can do is we can create the message here, right? The string message, right? And we can create the message, here, right? Message plus I, right? So this message has been created. Now what it will do, now this message has to be published where? This message has to be published into a queue. So publisher needs queue where the message would be published. So let's create the variable here, the message queue, right? And let's give the name to this publisher as well. For example, private string name, right? Now let's define the constructor as well. The publisher has the message queue and the name, right? And let's define one publish method here, right? Which generic message which would publish the message. So what it will do, it will just publish the message into the queue, right? So it will just publish the message into the queue. Let's log this name. We are just giving this name into this is out statement, and can just write publishing, and then we can just write message, right? This message has been published, and now under the run method, what we need to call, we need to call the publish method, right? Now publish message, our job is done. Now while publishing continuously, we can just, for simulation to see the real behavior, what I can do is I can just give the 200 milliseconds delay, if that sounds okay, right? Let's surround this with the try catch block, right? So what I can do here is I can print the exception occurred in, we can print the name here, right? And as well as name, and what we can do is we can just write the e.get message. Now our publisher job is done, right? Now let's see the code for the publisher. Publisher have the message queue and the name is given to the publisher, right? The run method of the publisher, what it is trying to do, it is trying to create the message which has to be published, and at the end we are calling the publish method which would publish the message into the queue. And thread.sleep is just for simulation so that we can see the behavior while running the code, right? So that's how the publisher code will look like. It is all right. Now similar code here, the subscriber as well. What I will do is I'll just copy this message queue, and because subscriber also has to consume the messages from the queue, right? Now what we need to do, we need to define the constructor, right? That's all right. Now what else we need to do? Now as we discussed, subscriber has to continuously poll, right? Subscriber has to continuously poll, okay, are there any messages, are there any messages, how we can ensure that it continuously polls? So it simply means we need some kind of while loop, right? So while true should be there, right? So while true should be there, okay, then what we can do is, what else we can do? Now here I need to check, okay, that queue message queue dot subscribe, right? So if the message, right, is not equal to null, right, we can just print the messages that the subscriber has consumed, right, consumed this message, right? And just for simulation we can give the thread.sleep here as well. Let's assume the 100 milliseconds would be enough, I guess, right? Now let's surround this as well with the try catch block, and sys out. Now exception occurred in, right, name, and here also what we'll do is, now our subscriber is also done. Now if you see, we have the subscriber that is also running as a thread, the publisher that is also running as a thread, but we will tweak this publisher later on. But just for simplicity, just for basic skeleton, we have the publisher. The publisher run method, what it will do is it will just publish the messages, 5 messages to the queue, and the subscriber will continuously checking, okay, are there any new messages, are there any new messages? If there are, right, so it would receive the message and print out the message. That is the basic flow for this publisher subscriber. Now how we can run this program? For that we need to define the main client, right? So under this we have to define the publisher subscriber, instantiate the publisher subscriber classes, right? Now as you can see, we have created the publisher and the subscriber as a different thread. Now how we can run this? We already seen in the earlier multi-threading videos, right, how we can start the thread, right? So just for better understanding, we can use the executor service here. For example, the executors dot new fax thread pools. For example, I can just assume here is 5, right? I can just introduce the local variable, right? Now what I need to do is I need to create the publisher and the subscriber modules, right? Now what I can do is publisher 1 new publisher, right? So first of all we need to give the message queue as well, which will hold the data structure. Message queue, right? Now the publisher has to give the message queue, and let's give this name publisher 1, right? Now similarly we have to create the subscriber 1, right? Subscriber, right? Subscriber 1, and here also I need to give the subscriber 1, right? Now how I can create this as a separate thread? So it's very simple. If we're using the executor service, what we can do is executor.service.execute. We can just pass the publisher 1, and we can just pass the subscriber 1, right? So our job is done. So let's run this code and see what is the behavior. Let's firstly validate whether all the code is correct or not. The queue is already there, is already initialized. As and when the message is getting published, it is getting added to the queue. If the queue is not empty, we are just returning the queue.remove.0, otherwise it would return null, right? The publisher would publish 5 messages, the subscriber would continuously check, is continuously running, right, and checking are there any new messages or not. If yes, it is just consuming, says out the message. Yeah, the code looks fine. Let's run the code and see how it behaves. Okay, let's run it and see how it behaves. And the code is just getting run. So if you see here, it looks like it would work fine, right? Publisher 1 publishing message 1, publisher 1 publishing message 2, and the subscriber 1 consumed message 1, subscriber 1 consumed message 2, subscriber 1 consumed message 3, 4, 5. So each and every message is getting published and consumed fine, right? Now let's introduce multiple threads, right, and see the behavior, what happens in that case. So I'm just quickly creating the multiple publisher threads as well as the multiple subscriber threads and see how it behaves in that case, right? So if you see here, I'm just doing that, right? So what I can do here is right now I've just created one more publisher thread and one more subscriber thread. Now let's run the same code again, right? Let's run it again and see how it behaves, right? So if you see here how it is behaving, the subscriber 1, right, and the subscriber 2, so each and every, it looks like it is working fine, right? The publisher 1 publishing message 1, the subscriber 2 consumed message 1, right, and subscriber 2 consumed message 2, subscriber 1 consumed message 1. So each and every message is getting published and consumed. It looks like it is working fine, but there could be some inconsistencies. I will just try to show out. So let's run it one more time and see. Now if you see the behavior, so ideally what should happen right? The subscriber 1 should consume the message 5 only one time, but how it is behaving as of now, the subscriber 1 is also consuming message 5 twice, right? And subscriber 2 is consuming message 4, right? So each and every uh, subscriber is means the message 5 is being consumed by the same subscriber, right? And there are more inconsistencies in the data can occur. Why it is so? Because the linked list data structure is not at all thread safe, right? So as and when multiple operations are trying to manipulate or trying to modify the linked list at the same time, you can see the inconsistencies happening. You can't see in a very, you can say, if you are running a very large use case or the large business case application, there you would be able to see the actual thing happening. But in our case, it might happen, but there are, as of now, there are only 2 threads. But when you have 100 of threads or 10 threads, 20 threads, then you can easily simulate this problem. So how we can fix this is, so in that case, how we can fix this problem? So if there are inconsistencies, how we can fix this problem? So we have to fix this problem with the kind of the synchronization. The if one thread is manipulating or modifying the list at the same time and the other thread is also coming, for example, if one thread is adding to the linked list, right, and if other thread, the second thread, comes and removing from the linked list, so it should wait until unless the first thread should complete its operation. So this is how we need to perform. So how we can do here is, so we can either, we can, as I have already shown in the earlier multi-threading videos, you can simply use the synchronized keyword along with the method, right? This is the simpler approach, right? But in many of the use cases or in reality, you don't actually use the synchronized keyword along with the method. It actually depends on the use case, how the method, how much the critical section has to be run by a thread, right? So as we can see here, the critical section code only in this method, so we can use this synchronized method along with the method name as well. And also there is other way which I will generally, which I usually follow, right? So what you can do is, so you can create the private object. Let's give this name, that object lock, right? So this is a kind of object which has been created. What you can do is, now you can do the synchronized lock. So as and when any thread is trying to you can say, as and when any thread is trying to access or add the message into this queue, right, it should take a lock first before adding the message into the queue. Once the message is being added, once the message is published, right, so what you can do is lock dot notify, right, so that you can notify the blocked threads, now they can access this queue, right? So similarly here also what you can do is synchronized lock, right? Now here we need to wait, this thread should wait actually if any of the thread is already manipulating or accessing the queue, has already taken a lock, right? So what we can do here is, while this queue, right, if this queue is empty, right, so in that case what it will do is, it should wait in that case, right? So I'm just doing the thread dot current thread dot get name, right, and I'm just writing the waiting for new messages. Let's assume this is the case, and what we can do is lock dot wait, right? So this is how we have to write. Now at the end of this synchronized, at the end of this while, if this queue is, if there are already messages into this queue, so what should happen, the message can be removed from this queue and it should process, right? So what we can do here is string, right, string message is equal to null, and what I can do here is message and return message. So this is the simpler change I can do, right? And what I can do here is I can just I can just throw the interrupted exception, the calling thread that is already handling here in the subscriber method, right? So the subscribe method, what it is actually doing, so subscribe method, now it would wait until unless the lock is not available, right? Now if we run this program, right, now it should work fine. In that case it should work fine, right? Let's run this program and see the behavior, how it behaves now, right? Now you can see the subscriber is into the waiting state, right, until unless there are new messages added by the queue, added into the queue. Now let's understand the behavior of the publisher subscriber with respect to thread states, right? So let's see what are the behavior when the publisher is running, when the subscriber is running, and so on, right? So let's understand the behavior of the threads, publisher subscriber threads, when they are at different conditions, right? So as you can see, all the publishers subscribers initially when we execute, that would go into the runnable state, right? Now there could be three conditions: either queue is empty, or the publisher is running, or the subscriber is running, right? There are no further cases, right? Now let's assume the queue is empty or the subscriber is running. Let's assume the subscriber is running. So what the code we have written, right? So what the code we have written, let's see the subscriber, while the queue is empty, right? While the queue is empty, it would go into the waiting state. Now what would happen in this case? So as and when, if the queue is empty and subscriber gets a chance and moved into the running state, so it will firstly check if the queue is empty, where the subscriber would go, it would go into the waiting state if the queue is empty, that is for sure. Now as and when the publisher is running, right, so publishers are running by taking a lock onto the object, right, whenever they are adding any message to the queue. So publisher is adding the message to the queue, right? At a time only single publisher can take a lock, right? So the publisher has taken a lock, and what would happen, the subscribers and the other publishers would be blocked, right? So if the queue is full, if the already messages are there, where the threads would be, right, if the publisher is running, the threads would be in the block state, because the lock has already been acquired by some other publisher, right? Now when subscriber is running, right, when subscriber is running, for example subscriber 1 is running, right, where the publisher would go, publisher would be into the block state, right, if the lock has already been acquired by the subscriber thread. So this is how the different thread states would occur in this code, right? Now let's see the code once again. So if you see the code, we have taken a linked list and we are doing wait, notifying the other threads, okay, the at a time only single thread can access the linked list, okay. So what is our main purpose? Main purpose is to store the message, right, in a thread safe manner. So if any of the threads who are trying to access the same queue again, right, or adding or removing the queue, removing the message from the queue, it should happen in a thread safe manner. So we can think of more, okay, is there any data structure readily available in Java which we can use and take an advantage? Okay, so yes, there is a data structure, so that we can use that and take an advantage. We can offload all this responsibility. For example, the blocking queue is already there, right? The blocking queue is already there, and here we can use the linked blocking queue, right? It is very simple, and we have what we have done, we have just taken the blocking queue, and the rest of the all the code is same. And let's see what happens actually, right? So what would happen, let's see, right? So the publisher, consumer, right, everything is running fine, right? Because why it is fine? Now we don't need to give any conditions. If the queue is empty, while the queue is empty, just go into the waiting state. We don't need to handle all these cases, because take method is provided by the blocking queue is a blocking call. If the queue is empty, this thread would just be blocked, right? It would just be into the waiting state. What all things we are doing earlier, that internally all things are done by the blocking queue internally. We don't need to handle all these complexities, right? Now our job is very simple, right? Now we have done the blocking queue. Now what was the second requirement? The second requirement is user should be able to stop the publisher and subscriber. Now how we can do that? Now the simple thing is, how we can do is, the executor service also provides some kind of, you can say, the shutdown method is already there, right? So but the question is again, so does shutdown method uh, ensures that threads running should be stopped gracefully? No, it doesn't happen in that manner, right? For example, if I do the shutdown method, right, and or the shutdown no method, let's assume this is the method, right? Now if we call the shutdown no method, does it stop all the threads gracefully? No. Let's run this program. Now let's run this program and see how the things are working, right? So if you see here, now if you see, only publishing the messages are being published by the publisher, and the subscriber too has not retrieved any message, because shutdown no forceful termination of the threads. It doesn't terminate threads in a graceful manner. Okay, how we can do it? Let's give some sleep, right, to ensure all the messages are processed. Let's assume we are given a sleep for 5 seconds, right? Try catch, right? So here what we can do is, we are just giving a sleep time to ensure this publisher and subscriber should consume all the messages, right? Now let's call the shutdown method, right? So shutdown method. So now shutdown method, so does it, so if we call this shutdown method, so do all the subscribers shut down? Okay, let's see this as well. If we are using shutdown method, what would happen in this case? Let's see. But our code is still running, it is not getting shut down, right? So it simply means the threads are still running. For example, the subscribers, right, the while true loop is there, right? So it is still running, right? It is not getting stopped. So to stop this, how we can do that, right? So we have to make a code changes for this as well. How we can do is, as we have already seen, if you have seen my earlier video, the volatile and the synchronized difference, what we can take an advantage of that volatile keyword here, right? What we can do is, we can tag volatile boolean, right, running is equal to true. By default, let's assume this is true, right? And what we can do here is, we can do what here is, we can provide some utility methods. For example, first of all, we can provide the one method which would be triggered by the user. For example, the stop method, this would be triggered by the user as and when he wants to stop this publisher subscriber library. So what it will do is, it will mark this running flag as false, right? So it would mark this running flag as false. Now what we can do is, we can create one more method which check, okay, if is my message queue is still running or not, right? So what it will do is, it will return the running flag, right? Now we have given two methods. This would be triggered by the user, right, to stop the publisher subscriber model. Now where this is running would be useful. Okay, now if you see here, as we have seen in the earlier videos as well, so we can take an advantage of is running here, right? How? we can take an advantages of if message queue is running, right? So instead of true loop, what we can do is, if the message queue is running, we keep on subscribing and consuming the messages. If message queue is stopped, right, then we can stop the subscriber thread as well, right? Now what we can do here is, we can do message queue, right, dot stop, right? Now we can do stop, and then what we can do here is executor service dot shutdown. Let's see in this case what should happen. Does it stop or not? Let's see how it happens after 5 seconds. Does it stop or not? Okay, so it is still not stopped, right? Although we have run the stop command, or call the stop method, right? And here we have made the running flag as false, right? And we have called the shutdown method as well on the executor service, but still the program kept running all the time. Why it is so, right? So it should not happen, right? Now let's look at the code what we have done right now, right? So stop, so it simply means the subscriber thread somehow keeps running, right? So we have the while loop is running based on the is running flag, so while loop is fine, right? So it should, as and when the running flag is false, it should come out of this while loop, right? So somehow it is not coming out of this while loop, right? But here if you see, the running flag is simply marked as false. That is all right. Now let's dig into the subscribe method. What is happening? So yes, there is the problem, right? In the subscribe method, we are calling the take method onto this blocking queue. Now the take method is what? Take method is a blocking call. So the thread where it is in the waiting state, right? It keeps in the waiting state, right? So it is just stuck at this point. It is not going beyond this, so that it can quickly check the is running flag and it can come out of it. But the code is stuck where? Here, the queue.take method, right? How we can fix this? It's a very simple fix. What we can do is, instead of take, we can just, there is one more method, the poll method. We can take an advantage for that, right? So instead of take method, we can call the poll method. It would come out of the waiting state after 2 seconds. No matter whether the message is available or not, it would come out of this waiting state, right? So I guess with this the code should work fine. Let's rerun the code and see how it behaves now, right? So it should work fine as far my understanding. Let's see how it works, right? Now let's wait for yes. Now if you see, the code is fine, right? We can just we can just have one sys out here as well, right? So we can do here name and stopped gracefully, right? So we can just have this sys out statement there, and instead of this, what we can do here is, we can just give 4000 would be fine, 4 seconds would be fine. Let's rerun the program again and see how it behaves now, right? Now all the publisher subscribers are running fine. Everyone has published subscribed the message. Now if you see here, it has come out of this while loop, right? Subscriber 2 also stopped gracefully, subscriber 1 also stopped gracefully. So this is how you can approach this basic problem, right? So for the guys who are having close to 1 or 2 years of experience, this is the bare minimum publisher subscriber code which is expected by you in the interview. For the candidates who are having 1 to 2 years or 3 years of experience, this is the bare minimum code you should be able to run no matter how, right? So with this this would be the bare minimum code for 1 to 2 years of experience, guys. But the guys who are having more than 5 years of experience, right? So there, the interviewer would be expecting much more from you, not just this much, right? Now the interviewer would be expecting much more in terms of how the callbacks are being handled, right? And how flexible is your, you can say, the code. Are you following the all the solid principles, everything, right? Now we'll just move forward more advanced version of it. Let's move to the further requirements, right? So what are the further requirements, right? Now we have completed few of the requirements, right? The requirement number one was there could be multiple publisher and subscriber threads, that we have already achieved. The requirement number two was the user should be able to stop the publisher subscriber model, that also we have achieved with the help of volatile keyword along with running flag, right? And the requirement number three is there should be kind of callback functionality, that we would discuss later, right? The requirement number fourth is there should be different type of messages sent over this library. And the main requirement is the, for example, the order updates should not be delayed if there is a high inflow of notification updates, right? So the processing of the messages should be done in an isolation, right? So that the other type of messages should not hamper the different type of messages, right? So this is the fourth requirement. So let's quickly complete this fourth requirement, right? How we can achieve this, right? So just let's discuss. Okay, let's discuss what we have done till now. Till now, what we have is we have a shared message queue that we have created, right? And there are different publisher threads and could be multiple subscriber threads, right? Different publisher, different subscriber threads, but the shared message queue is the single, right? But now to achieve fourth requirement, right, to process the messages in an isolation, the order updates, notification updates should not hamper each other, right? So to support this requirement, we somehow need different message queue, otherwise there is no way to provide or implement this functionality, right? So this is how actually Kafka also does, right? So the topics or the queues has to be different. For example, the order update, the queue has to be different. For notification update, the queue has to be different. So if you see the diagram, to fulfill the fourth requirement, the order update publisher, just for simplicity you can assume this is the publisher name, right? And the order updates is the actually the queue name on which the messages would be published. Whenever this publisher would start, it would publish the message onto this queue. And similarly, there could be different subscriber who would be subscribing from this order updates queue, and the different threads could also be there for the same queue, right? So there also the same functionality is there, right? So different queues to support this functionality, right? Now let's see how we can do this in a code, right? So what we can do is, or what I will do is, till now we have the v1 package under which all the code is there. What I will do is I'll just create the package v2, right? And I'll just copy all the code into this v2 package, right? So that it would be easy for you also to check how we have incrementally changed the design with respect to requirements, right? Now this is the message queue, and this is the main client, this is the publisher, this is the subscriber. These are the four classes which we have created. Now as you can see on the message queue, to fulfill the fourth requirement, we need somehow different instances of this message queue, right? So who will hold this different queues, right? Whose responsibility is this? Is that a responsibility for a publisher? No, publisher has to deal with only one particular queue on which it has to publish the message. So is it a responsibility of subscriber? No. For holding the different queues? No. The subscriber only needs an information on which it has to subscribe, right? So subscriber knows only about the single queue from which it would subscribe the messages, right? So who would hold this responsibility for holding the different queues, right? So that is where the brokers come, right? For example, if you have already seen my Kafka 0 to Hero series, right? So there we have gone through, I have explained all the concepts, right? What is the responsibility of broker, right? So generally that is where the brokers come in picture, right? So similar concept here. What we will do is we will create one class, right? For example, the message broker, right? So this broker would hold all the queues, right? For example, we can have the map here, right? The map string, and we can have here is the message queue, right? The message queue would be there, and we can have is queue map and the concurrent hash map, right? So this is the kind of map we can have. So what it will hold is the string key is the queue name, right? So if you see, I'll just comment it, right? So this key value pair is key is queue name, right? And value is the message queue, right? So for different type of queues, queue, only one message queue would be there, right? For order update there would be one message queue, for notification update there would be one message queue, and similarly for other type of queues, right? Now message broker, what is its responsibility? Its responsibility is to return the queue, particular queue, to the publisher and the subscriber, so that publisher can publish onto that particular queue and subscriber can also subscribe from that particular queue. So we need to somehow override, implement this method, right? Message queue, right? Get message queue, right? So here what we will do is, here the publisher would have to provide the queue name, right, on which it has to publish the data. That's how actually happens in real life, right? So here the queue name has to be there, right? So queue map dot, we can use the compute if absent, right? If the queue message queue is not there, it would create the message queue, right, and add it into the map, right? So that's how we can just simply get the message queue. Now who will provide the name? Okay, if you have rigorously followed my Kafka 0 to Hero series, you must have seen there, while publishing the messages onto the Kafka, we usually specify on which topic this message has to be published. So whose responsibility is this? This is the responsibility for client, right? So client will have to provide, okay, that this publisher would publish the message onto this particular queue, right? So this is the responsibility for a client. So now what we can do here is we can just quickly tweak the publisher and subscriber code, right? Now if you see here, the publisher uses the message queue, right? But now what we need to support, this publisher could be order publisher, could be notification publisher. So the queue should also be the appropriate one, right? So how we can get the appropriate queue, right? So what you can do here is, now the message queue is no more should be provided by the client. What has to provide? It has to provide the message broker, right? So message broker has to be provided by the client, right? And here what we can have is, it has the message broker, and here also we can have the message queue, right? Message queue, right? Message broker, from message broker we can get the message queue, right? So assume this is the name for the particular topic or queue, right, for on which the message has to be published, right? Now the message broker, we can just simply instance this message broker as well, right? Now publisher changes are done. Just one more thing is required. Let's quickly do the subscriber changes, right? So here also the same changes. I'll just quickly copy paste this, right? Message broker, okay. I'll just quickly copy paste this message broker, right? And this message broker has to be provided by the particular client, right? And this queue has to be retrieved from the message broker based on the queue name, what the subscriber has to subscribe, right? And here also what we can do is, this dot message broker message broker, right? Now we have done the changes for this. Now if you see earlier, to stop the publisher subscriber model, how the code, how was the code? So what was happening, actually we have taken the running flag into this message queue. So first question, is it a responsibility for the message queue? No, the running responsibility, not a responsibility for message queue. So whose responsibility is actually? It is the responsibility for the broker. So usually client, actually whenever you have to brought down any of the publisher subscriber model, right? So what you do, actually you bring down the broker, right? So broker should have this code, right? So is running flag, everything, what, whose responsibility is this? Is this the responsibility for the broker? So what we can do here is quickly, so we can have the volatile flag running here, and from the message queue what we can do is we can just quickly copy paste all these message methods, and we can just remove these methods from the message queue, right? And now our message queue is simply looks like this. It just holds the blocking queue, and message broker is holding the queue map, which will hold the particular queue for a which will hold the message queue object for a particular queue, right? So that's how it would look like. Now let's see again the publisher, right? So here the publisher would publish the message queue. From where we got the message queue? From the broker, based on the queue name, right? So here we can do the one change here, right? So for example, here also we can use the message broker is running. If the message broker is running, then only we should publish the message. So the publish is also working, is also done. Now let's see the subscriber. So if you see, the message broker is running. Now there are very minimal changes which we have done, right? And with these changes, the publisher also, the subscriber also looks fine, right? We have used the message broker, message queue we have retrieved from the message broker, and rest of the things are remain same. Now the publisher also the same thing, right? Now let's see the message queue. Message queue is nothing, just having the link blocking queue, that is also done. Now let's see the message broker. Message broker has the running and the queue map holding the different type of queues. Let's see the main client, how it should look like, right? So actually what happens, the here the message queue was being used earlier. Now here what it should be used, the message broker should be used, right? So here the message broker should be used, and it should be like this, right? Message broker, message broker, message broker, right? And message broker. Now all the changes are done. Just for with respect to what we have seen in the diagram, what we can do is we can just consider this is the name of the queue, right? So the publisher one, or we can give the order updates, right? Similarly you can just order updates publisher, right? We can just give this, and similarly for this we can give the notification updates publisher, right? So what we can give here is notif updates, right? So similarly here what we can do here is we can have the subscriber, and under the subscriber we can give the order updates, and the other subscriber could be for the notification updates, right? So I guess we are done. Here it should be order publisher, here should be notification publisher, here should be order update subscriber, right? So we can just quickly rename a few things. Here the notification updates subscriber, right? So what we can do here is we can just tweak this change. Now I guess we are done, right? Now if you see here, the message broker is being used. Now let's run the program and let's see how it works actually, right? Now still the publisher is publishing the messages onto this particular queue. Everything should work fine. What we can do here is instead of this, what we can do here is message just to see whether the particular message is retrieved by the particular subscriber or not. What we have done, we have just append the name also along with the message, right? So on the subscriber side also, what we can do is name. Here we were using the name, and here the message, name, publishing message. Okay, that's all right. Name, publishing message, yeah, that's all right. Now let's run the code. Let's run the code and see if it works fine or not, right? So our fourth requirement should also work fine. Let's see the code running, right? So if you see the code, right, order updates, publishing order updates 1. So order updates, consumer only consumed order updates message 1. Notification updates, consuming only notification updates messages, right? Nowhere you would see the notification updates message, updates subscriber is consuming the order updates, right? So they are working completely in an isolation manner, right? So that's how we can fulfill the fourth requirement. You can see how easy it was to implement or incorporate just one wrapper class and just few changes here and there, and our job is done, right? Now let's discuss the third requirement, right? So the third requirement is we need to somehow provide a provision to the client to run its own business logic when the message is published successfully and the message is received successfully, right? So how we can achieve this requirement, right? So let's discuss that. How we can achieve is, right? So till now what we have actually, right? So we need to somehow provide this provision, right? So till now what, let's see the publisher, how our publisher code is as of now, right? So what we have is, we have the publisher, right, which is publishing the messages to the queue, right? And the queue is getting retrieved from the broker, right? But if you see the run method for this, right, so the run method is just a simply for loop, right? So it is just iterating over the for loop. One random message has been generated and getting published onto the queue, right? So as and when the message is published onto the queue, somehow the client has to run its own code, right? So how it can be done, right? So usually what happens in real life, right? So you can visualize this diagram, this one, right? The publisher and the subscriber, they are using the shared resource. Let's consider the one queue at a time, at just for simplicity, right? For example, this is the queue, right? And this is the queue which is being used by the publisher and the subscriber, right? Now the client has to publish some kind of message, right, which internally publisher will publish onto this queue, right? And similarly the client should have some business logic. As and when the subscriber consumes the message, that business logic has to be triggered, right? This is the main functionality, right? But if you have seen, the publisher is, as of now, it is just generating random message, right? But ideally the publisher gets the message from where? From the client, right? So client will publish. So we have to change the publisher code in such a manner that it should publish the message whatever it gets from the client, right? So but the thing is, how we can do that, right? How we can do that? Because publisher method should also run continuously in that case, right? So how we can do this? The publisher would keep publishing the message, right? So how we can achieve this is, right, so for example, this is some kind of generic publisher, right? The order update or any kind of publisher. What we can have is, we have to somehow hold one more queue, right? We have to somehow one more queue. For example, the queue is there, right? We can use the publisher queue, right? Now why I am using this, I'll just explain you, right? I'll just explain you why it is needed. Because we need to somehow run the publisher continuously, right? Otherwise every time when client publishes the message, we can't spawn a new thread and publish the message in that manner, right? So it can't be done, right? So what we can do is, we can just use the concurrent linked queue, right? So it is also a thread safe queue, right? So whenever the client is publishing the message, right, whenever the client is publishing the message, it will publish on which queue? It will publish on this queue, right? It will publish on this queue. So it will publish on this queue, add message, right? Now this message queue, who will publish on this message queue then, right? So who will publish on this message queue? Okay, so this would be called, actually this would also be called, now this this would be called when the actual message has to be published, right? So as of now, what, first of all we need to remove this for loop, right, somehow, right? How we can do this? Simply we can just get rid of this for loop, right? So here also we have to run the publisher in a continuous fashion. What we can do is we can just use the while message broker is running, right? And or if the message broker is running, or the publisher queue, right, or the publisher queue, right, publisher queue is not empty, right? If there are still pending messages which has been published by the client, right, in this case, right, so that has also be published, right? So in this case what it has to done, so it has to get the message from where? So publisher queue dot poll, right? So in this manner our publisher would also continue to run, would also running continuously, right? Now in this case, once this message got, now on this point, at this point it has to publish the message to the broker or to the actual queue, right? So this is where it has to be published, right? Now who will, this method would be running here, right? So message queue would be published here, right? Now if you see, our job is done almost. Now once this is done, here is where we need to implement the callback, because this is where the message has been published, right? This is where the callback has to be triggered, right? So somehow we need to trigger the callback at this point, right? Similarly on the subscriber side, when it got the message, right, when it got the message, this is where it got the message, right? At this point trigger the callback, right? That is where the subscriber has successfully consumed the message, right? So that is where the callback has to be triggered. So we have just refactored code. Why? The publisher has to run continuously. Otherwise, if we don't provide some kind of while loop, right, so publisher won't be able to run continuously. Otherwise, if you don't use some kind of, you can say some kind of queue, right, some kind of queue from where it would get the message. And this is how actually happens in real life, right? If you see the Kafka, right, so there also they have some property, the one call onto the broker, the REST API has to be sent to broker just in a one batch, right? So in a single batch there are 10 or 100 or 50 messages sent in just one single REST call, right? So you can assume this functionality is achieved using this queue, right? So just for simulation we can have this thread sleep for some time, right, so to prevent busy waiting. So that's how we can do this. Now the remaining part is we have to somehow do the somehow we need to implement the callbacks, right? Now let's see how we can, what are the approaches and how we can do the implement the callback functionality, right? So if this has to be a library, right, so we are designing a publisher subscriber library which can be used by many of your other projects, right? Now how we can do this? If publisher subscriber is in a library, how the library can know, okay, that this is the business logic which has to be called, right? The library doesn't know any client or anything, right? So this is where the callbacks comes in picture, right? The same thing happens in the real life, like RabbitMQ, JMS, Kafka, everywhere, right? So how we can implement this callbacks, right? So implementing the callbacks, we have two options, right? So the first option is by introducing the interfaces, right? So for example, we can have one interface for publisher callback, for example the onPublish callback. So it would provide one method on message published, right, and the other interface could be on subscribe callback, right. It would provide one method, the on message received, right. So now we have this interface. Now the next question comes, who will implement this interface, right, and how the client code would be called, right. Okay, so these interfaces would be provided by whom? Provided by the library. That's all right. Now who will implement this interface? The implementation of this interface could be done in two places, right. The first way is either the publisher subscriber, the publisher subscriber code which we have already written, right, either those classes implement this interface. The second approach is, or the client will implement this interface. There are all two ways, right. Now let's see if publisher or the subscriber implements this interface, right. So if publisher has to implement this interface, for example, publisher implements on publish callback as well as the runnable, and similarly subscriber also implements the on subscribe callback and the runnable, right. So here we have given the on message published, right, and on message received, right, somehow, right. But how the client code would be called? How the client code would be called? So if the publisher or the subscriber implements the interface, so there is no other way to extend this class, right. So to provide client its own behavior, right, so client has to, only way left over to client is to extend this publisher or the subscriber, right. So in this case, how the client code would look like? So client code would look like, client publisher can also extend this publisher and can override this behavior. That is the only way. There is no other mechanism, right. So client publisher has to extend this publisher, and similarly the client subscriber has to extend this subscriber and implement the behavior, right. This is the first approach. If we go with the interfaces, and implementation is done by the publisher and the subscriber. Now let's see the second option. The second option is if the client implements this interface. Now let's assume the on publisher callback is provided by the library, right. Now who will implement this interface? The client would implement this interface. Let's assume this is the client implementation. It is not present in our library, right. It is under the client who is using our library, right. So message published callback IMPL, this is the class in the client code, right. It will implement this interface, right, and it will just implement the methods, right. Now next question comes, okay, how this callback would be triggered, right, how this callback would be triggered. Now in this case, if client is implementing this interfaces, right, but somehow library has to know, right, this is the implementation it has to use, right, otherwise library keep on using its own default implementation, right. So somehow library has to be notified, okay, that this is the implementation you should use once you publish the message successfully, or once you receive the message successfully. So where it can be done? It can be done passed in a constructor. So if you have the publisher, right, publisher implementing the runnable interface, and publisher also should accept some kind of interface in a constructor only, where you can provide the callback interface implementation. Either it could be using Java 8 function interfaces or the Java 8 supplier interfaces, any way, but the implementation should be provided to this publisher, so that publisher can call this callback. Otherwise there is no way how a library can call this callback, right. So the client has to provide this implementation. Now if we go with this approach, right, but imagine now if there are multiple callbacks. These are just two simple callbacks which we are discussing: on message published, on message received, right. But there could be much more callbacks, like error callbacks, acknowledgement callbacks, and much more, right. If the broker is down, there could be different callbacks, right. So there are many kind of different callbacks, right, or the different strategies should be there, right. So it would be very difficult to accommodate so many callbacks. So client has to pass these many implementations, right, into the constructor, right. So this is not a recommended choice. We should not use this way, because otherwise the client has to remember, okay, I need to implement this interface, I need to do this thing, right. So the other thing is, if later on the library decides, okay, that this interface should expose this new method, right, so in that case all the client code would be broken, right? So simply we can rule out option B. There is no way to, there should not be, we should not go with this approach actually, right? So okay, we should not go with this approach. With which approach we should go? With the option 1. So in that option 1, what we were using the interface implementation, and client was overriding the method, right? Now if client is overriding the method, do we really need an interface? That is the next question, right? No, we don't need an interface. Abstract class can do the job perfectly for us. How the abstract class can do the job for us? Simply we can create the publisher as abstract and the subscriber also as abstract, right? And in this publisher and the subscriber, we can just simply provide two methods, the abstract methods, on message published and on message received. Right now, if you see the client code, how the client code would look like, the client has to just extend this publisher and provide its own behavior, right? Similarly, client subscriber can extend this subscriber and can provide its own behavior, right? That is why you have seen most of the libraries provide the abstract classes already there. You just to override the implementation, to override the behavior, you just extend these classes, right? That is why most of the messaging libraries frameworks does this manner, right? Now let's do the code changes for this quickly, right? So quickly we have discussed all the things, right? Now what we have to do, we have to just declare this class as abstract, right? So one change done, right? Now what other change we need? We need public abstract, right, void on message publish, right? So this is the second change, right? And here we can just provide the message, right? So this is the abstract method which has to be overridden by whom? By the client, right? Similarly, if you see the subscriber, right, if you see the subscriber, how we can do this, right? So subscriber also, what it needs to be done? The abstract class, right? Abstract class. And here also what we can do is abstract, right, void on message received, right, string message. Our job is done, right? So simple two abstract methods we have provided, right? And now it's up to the client. It has to implement this or extend this publisher and this subscriber, and can simply use this method, right? Now the other thing is, where we need to implement this callback. This callback has to be triggered from where? From here. Simple, right? From here the callbacks would be triggered, right? So callback would be triggered here. And similarly from the subscriber, where the callback would be triggered? Callback would has to be triggered here, right? On message received, right? Now our job is simply done, right? Now if you see, I can just do this thing, right? I can just provide few ms, sorry for that. Now publisher, that is done. Callback has to be given here. Now publisher subscriber is done. What we can do here is, now the publisher class has to be extensible, right? So order updates publisher, right? Or you can just order updates publisher, that's fine, right? What it needs to do, it needs to extend this publisher, right? So if you see the constructor, that is done, right? Now what needs to be done? It needs to be override methods. Which method? The on message publish method, right? So on message publish method. Now here what we can do is just one thing, we can just do here the protected, so that we can use the same name here as well, right? Order updates, right? And now we can use the same name, right? So custom published, right? So just custom published message, right? So we have just done with this, right? The order updates publisher is done. Similarly what we can do is the order updates subscriber, right? So what we can do is extends subscriber, right? Now what we have to do, we have to just constructor, right, we have to just implement the methods, right? So here what we can do is, here also we need to do the protected, right? So what we can do is name, and you can say custom received, right, message, right? If you see the subscriber, here we have removed publisher publishing, the callback has been triggered from there. Here it is polling continuously, and I guess we are done, right? Now just the main client changes needs to be done. Here what we need to do, we need to just do the order updates publisher, right? This we can comment as of now, right? And here we can do the order update subscriber, this we can comment, right? So that's how easy it is. Simply we have done very easily. If you see here, now the order updates publisher, right? Now just one more change which we need to do, who will publish the message, right? The order updates would publish the message, right? So here what we can do is void publish, right? So here we need to provide this message, right? So what we can do here is, right, so we have to use the publish publish message. Here what we can do is publish message, or in the, here we have the publish, right? We can't override this method. What we can do here is, as of now, we can just simply this publish message, and internally it calls which, it calls this method, right, which will internally call, adds the message into this queue. So I guess our job is done, right? So the publish message is publishing into this internal queue which is being used internally by this publisher, right? So that's how we can do this, right? So the main client, now there are no more publisher is continuously publishing the message, right? So what we have to do, we have to publish, right? Publish, right? For example, the order one placed, let's assume this is the message which we need to published, order one placed, order two placed, order three placed, order four placed, right? So that's easy it is. Now let's run the code and see if it works fine or not, right? I guess it should work fine, but let's see, right? So null pointer, okay, abstract queue add, message queue publisher, okay, queue, okay, I guess I got the problem, message queue, okay, the publisher queue continuously adding into this, that's all right. The subscriber, the problem is at the subscriber side, the publisher queue is not empty, okay, no, message broker is running, message queue, okay. Now what happens actually, it can be null, right? So what we can do here is, it can be message, because this is a poll statement, right? So in this case the poll method can return the null value if there are no messages, right? So that is why we face this exception. Let's run the code again, right? So if we see the code again, let's see, it should subscribe the message, right? So if you see here, right, published order updates has published order one placed, right? Order updates consume custom received. So where we have this on the subscriber side, so subscriber has received this all the order updates, right? So order updates has been published successfully and the order updates has been received successfully. So it was how we can design this, right? So this is what is expecting from your interview if you are having an experience of close to 7-8 years of experience, right? So this is just a general pub sub model, but in the later videos I will design Kafka also the similar manner. It would be in a much more depth and I will cover all this in the next video, but just let's move forward. The other requirement, what is the other requirement, right? Now let's move forward with the other requirement which is left over, right? So let's discuss the last requirement, which is actually our library should be generic enough, right? So as of now, what is happening, we are just publishing and consuming the string messages, right? But our requirement was to support generic messages, right? Any kind of data structure can be supported by our library, the publisher subscriber library. Let's quickly do the changes for that, right? So for that, what I will do is I'll just create a package with the v3, okay, and I will just copy all the code here, right? So what is actually needed, right? So what is actually needed, this is no more needed. First of all, this publisher, right, this publisher, when it is publishing the message, it has to be in uh, any kind of data structure, right? So generic has to be supported, right? So how we can support the generic, it is just simple. We can just have this, right? The q also has to support in this manner, no, right? This is done, right? Now what is this, here also we need to provide this type safety, right? And message queue publisher, here what we can do here is we can consider this as object, right? Because it can be any kind of object, right? So we are done here. On message publish, here we can just use this t, right? If yes, so here if we go here, so here also we need to support the generics, right? So simple changes, right? So the order publisher, here also we are doing the simple changes, right? Now here also we need to provide the generic, right? So let's go with the publisher flow first. The publisher changes, it is publishing the message in a generic, right? Any kind of data structure, any kind of message can be published, right? Any kind of message callback, right? Or message publish, everything is done. Here the everything is done, right? So here the publisher changes are done. Now let's see the subscriber changes, right? So the subscriber also needs to consume the messages of any type, right? So here also the t, the generic should be there. Here it could be kind of, you can say the t, right? And here it should be t, right? Now our job is done, I believe. So here also it is t, the generics, I'm just providing the generics, that is it, right? So here also it should give t, I guess. Subscriber, let's see the subscriber changes. Subscriber changes are also done. Publisher changes, publishing, we are publishing the message of any type, right? And onto this queue as well, we are publishing the message of any type. And callback, we are getting the any kind of message, custom message which is expected, right? The subscriber, let's see the subscriber, right? On message received, that is also done. Now the order update subscriber, here also the changes are done, right? The order updates publisher, order update subscriber. So I guess we are done. Now here is the only changes what we need to do. We need to just provide the generics here, right? So that's how we have to do, right? So just this way we can string, right? So string, and here we can use this. Now if you see later on, you can here, as of now, if I publish any kind of message, right? For example, the publish message, it is what it is receiving, it is receiving generic message, right? So here it is receiving the string. So if I pass, for example, 1, right, it is giving the error, right? So any kind of generic, now it is up to the client what kind of object it has to pass onto this library, right? For example, for order updates there could be different schema, right? For notification update there could be different schema. So all those things would also be happened, right? Would also be incorporated with this library. Let's run this code quickly and see if it is working fine or not. Let's see the code changes. Yes, so it is working fine. Now we have supported the generics as well, right? So this was all I was trying to cover. So you can see when you go into the nitty-gritty details of the system, right, how we can design a particular publisher subscriber model, right? So you can see there could be different approaches, right? But you have to decide, okay, for example, in our case we have discussed very depth, right, why interfaces cannot be used, why the abstract class we need, okay, if we have to provide the callback functionality, how we can do that, what are the ways, right? So whenever any problem is thrown on you, just try to divide the problem into smaller problems and then try to solve it. Don't jump onto the problem, okay? Don't try to fulfill all the requirements in one go. That is never gonna happen, right? Just go with the flow, take one requirement at a time, right, and make your design, okay? But you have to consider the fact, okay, that this is the kind of future requirement which has to be supported. Just so from the beginning only, just keep the design in such a manner so that the future enhancements could also be supported, right? Now let's quickly see the class diagram, how it looks like actually, right? Now if you see the publisher and the subscriber, right, it is implementing the runnable interface, right, that is there. Now publisher and subscriber is holding what thing, right? It is having the message broker, right? So publisher subscriber is having the message broker, it is checking whether the broker is up and running. So in real life also, all the publishers, all the Kafka client libraries or any kind of RabbitMQ libraries, those also holds the message broker and keeps continuously checking that if the broker is running fine or not, is it up or not, right? And from this broker, the publisher and the subscriber gets the queue and the messages has to be published onto the specific queue. So the client side, the notification update publisher, the notification update subscriber, right? So they can extend this publisher and subscriber abstract classes and can provide its own implementations. As of now, we just have two methods, the on message received, on message published, but later on you can have any number of messages, for example the acknowledgements, the error callbacks, any kind of mechanisms you can have. So guys, this was all I had planned to cover. So stay tuned. In the next video we will be discussing the publisher subscriber model that would cover the push based mechanism, and later on I will be designing the complete Kafka library that would be much more in depth, right? So but with this would act as a base for any kind of publisher subscriber model, right? So guys, stay tuned and see you next video. So please, if you really like my explanation, do like, subscribe and comment on my channel. So I would try to answer each and every query. Now you can tweak this design and extend this design to whatever way you can. For example, you can design, you can extend this design with the few kind of few more parameters, right? The error callbacks, the acknowledgement callbacks, you can extend this design as much as you can. So guys, see you next video. Please do like, watch, comment and just enjoy. Thanks a lot.